Class 7, Science Chapter 9, Soil. Animated Science. Soil. Soil is a mixture of rock particles, humus, organic matter, air and water. It is one of the most important natural resources on Earth. Soil is important for life on Earth. Plants grow in soil. Plants make food. This food is made available for animals. Thus, the soil supports life on Earth. Soil is also the home for many animals, insects, worms, microbes. Let's learn more about soil formation, soil profile, soil composition, soil types, soil erosion, and soil conservation in this chapter. Soil formation. Soil formation is a slow, stepwise process. It takes thousands of years to form a layer of soil just a few centimeters thick. The rocks are broken down into soil particles by the action of wind, water, and climate over 1 million years. This natural process of breaking down of rocks is called weathering of rocks. Weathering is the breaking down of rocks on the Earth's surface caused by natural forces such as wind, water, climate, etc. Soil profile. Soil profile is the vertical section of the soil showing the different layers of soil. When we cut straight down into the soil is called soil profile. If we dig down straight into the soil, we can see 4 distinct layers of soil. These layers are distinguishable due to the color and size of particles. These layers are called horizons. A horizon. It is the uppermost layer of the soil. It is also called the topsoil. It is generally dark in color and is very rich in humus and minerals. The humus makes the soil fertile by providing nutrients to the growing plants. This layer is soft, porous, and can retain more water. The living organisms such as microbes, worms, rodents, moles, and beetles live in it. The roots of certain small plants also grow in it. B. Horizon. It is the middle layer of the soil. It is also called subsoil. This layer is compact and harder than the topsoil. It is yellowish-brown in color. It is rich in clay and minerals like iron. The roots from trees reach and remain in the subsoil. It is poor in humus or organic matter. Microbes and other living organisms are almost absent in the subsoil. C. Horizon. It contains small lumps of rocks. This layer has cracks and crevices in it. Bedrock. It is the lowermost layer of the soil. This layer is very hard and difficult to dig with a spade. This layer may store water or mineral oil in the crevices below. It is dug up for water or for oil. Soil composition. Soil is not the same at all places. The color and quality of soil differ from place to place. The main constituents of soil are sand, clay, silt, pebbles, humus, air and water. These constituents are of different sizes and color. Soil composition. Let's find out about the soil particles with this activity. To learn about the particles present in garden soil, collect some soil from the garden or a flower pot. It may contain some large-size particles of gravel. These can be removed by hand-picking or sieving. Place the rest of the soil in water in a beaker filled with water. Allow the soil particles to settle in water. Observe the different layers of soil formed in water. Size of soil particles. Gravel and pebbles. Larger than 2 mm feel coarse. Sand 2 to 0.05 mm feels gritty. Silt 0.05 to 0.002 mm feels like flour. Clay smaller than 0.002 feels sticky when wet. Soil types. The soil is classified on the basis of the proportion of particles of various sizes as follows. Sandy soil. The particles of this type of soil are too coarse. Soils with lots of sand have big spaces between the particles. They don't hold water or nutrients. The large spaces between the sand particles are filled with air. Hence, sand is well aerated. Sandy soils don't stick together very well. Plant roots can't hold onto this soil. But the big spaces do allow air into the soil. There are some plants that are able to grow in sandy topsoil by putting their roots deep through the sand to the subsoil. Clay soil. The particles of this type of soil are very fine. The spaces between soil particles are very tiny. When clay soil is dry, it's almost as hard as concrete. Water can be held in the tiny gaps between the particles of clay. So clayey soils have less air. Plant roots can't push through clayey soil. No air can get in from the surface. Most bacteria and other soil organisms that need oxygen can't breathe and survive in this soil. Clay soil is used to make pots, toys and statues. Loamy soil. Loam is an ideal blend of sand, clay and silt, and it is what gardener commonly looks for because it is considered as the best soil for almost any plant. It is the perfect soil for plants and soil organisms. This soil has enough large and small spaces for air and water to flow in. It also has enough clay to let it stick together and hold humus. It has the right water holding capacity for the growth of plants. Plant roots can easily grow through these spaces. Soil water. Soil has moisture in it. The water present in the soil is called soil water. On a hot summer day, if you happen to pass through a farmland, you must have noticed the air above the land shimmering. This is because the soil contains water. Due to the sun's heat, vapor is formed. The vapor coming out of the soil reflects the sunlight. Hence, the soil seems to shimmer on a hot summer day. This is due to the water present in the soil. Let us understand this with a simple experiment. Take a boiling tube. Put 2 spoonfuls of a soil sample in it. Heat it on flame and observe it. On heating, water in the soil evaporates and moves up and condenses on the cooler inner walls of the upper part of the boiling tube. This indicates the presence of moisture in the soil. Properties of soil. The ability of soil to absorb water is known as soil percolation. Let us understand this with soil percolation test or perk test. This test determines the time taken by water to pass down the soil. Take 3 glass funnels, 3 stands, 3 pieces of cotton gauze or bandage, and about 20 grams each of sand, clay and loam. Mount the funnels on stands, 1 on each stand. Place a piece of cotton gauze, 1 in each funnel. Pour sand in one, clay in the second funnel, and loam in the third funnel. Now pour 50 ml water slowly over each kind of soil. Observe the amount of water percolated, retained or absorbed by each kind of soil. Now calculate the rate of percolation of each soil by using the following formula. Percolation rate is equal to amount of water, that is ml, divided by percolation time, minutes. For example, suppose for one of the soils, it took 20 minutes for 200 ml of water to percolate. So rate of percolation is equal to 200 ml divided by 20 minutes is equal to 10 ml per minute. Hence, in this way, we can easily find the rate of percolation for each of our soil samples. Absorption of water by soils. Different soil types can hold different amounts of water, and it depends on 2 factors. Water absorption tendency. The amount of water a particular soil can absorb is its water absorption tendency. Water retention tendency. The capacity of the soil to hold water is its water retention capacity. Longer the time duration for which water is held in the soil, the higher is the water retention capacity. Example: clay soils absorb water very slowly but retain it well. Sandy soils absorb water well but do not hold it well. Loamy soils hold more water than sand. Let's understand this with an experiment. Take a plastic funnel, take a filter paper, fold it and place it in the funnel as shown below. Weigh 50 grams of powdered soil and pour it into the funnel. Measure a certain amount of water in a measuring cylinder and pour it drop by drop in the soil. Do not let all the water fall at one spot. Use a dropper for this purpose. Pour water all over the soil. Keep pouring the water till it starts dripping. Subtract the amount of water left in the cylinder with the amount of water you started with. This is the amount of water retained by the soil. Record your results in the following way. Weight of soil is equal to 50 grams. Initial volume of water in the measuring cylinder is equal to U ml. Final volume of water in the measuring cylinder is equal to V ml. Volume of water absorbed by the soil is equal to U minus V ml. Weight of water absorbed by the soil is equal to U minus Vg. 1 ml of water has a weight equal to 1 gram. Percentage of water absorbed is equal to U minus V divided by 50 into 100. Soil and crops. Soil at different places is different. The soil may be sandy, clay or loamy. Also, the color and texture of the soil is different at different places. Some soils are brown, some are black, and some are mixed colors. The soil is affected by the climate of a place, rainfall, wind, etc. The climatic factors as well as components of soil determine the various types of vegetation and crops that might grow in any region. For example, wheat, gram and sugarcane crops are grown in loam with more of clay which can retain water. Millets, jawar and bajra crops are grown in sandy regions. Peanuts grow well in sandy soils. For lentils or masoor and other pulses, loamy soils are required which drain water easily. Cotton grows well in loam or sandy loam which drains water easily and can hold plenty of air. Paddy is grown in soils rich in clay and organic matter, which has a good capacity to retain water. Soil erosion. The removal of soil by running water and wind is known as soil erosion. Soil erosion is a serious problem that farmers face today. It removes the fertile topsoil, reducing the productivity of the soil in that area. The major causes of soil erosion are deforestation. The removal of trees on a large scale is known as deforestation. The roots of trees and plants hold the soil particles together. When trees are removed, soil particles are left loose and can be easily carried away by running water and wind. Floods and heavy rainfall. Floods and heavy rainfall cause a lot of damage to the soil. Improper farming. Traditional methods of farming on hills makes it easier for wind and water to erode soil. Soil conservation. Reduction or prevention of soil erosion is called soil conservation. The following are some of the measures that help in conserving soil. Afforestation. The process of planting trees in large numbers is called afforestation. Flood control. Floods are controlled by building dams, constructing bunds. Embankments or mud walls should be constructed around hill slopes or fields to stop the flow of water. Terrace farming. In this method, suitable crops are grown on sloping ground, which is cut into large strips called terraces. Terrace farming reduces the speed with which the water flows down, reducing the amount of soil erosion.